Hi, this is question 6 from the June 2012 AQA Mechanics 3 paper. At noon, two ships A and B are a distance of 12 kilometers apart, with B on a bearing of 65 degrees from A. The ship B travels due north at a constant speed of 10 kilometers per hour. The ship A travels at a constant speed of 18 kilometers per hour. And we don't know the bearing at which ship A is travelling. For part A, we're asked to find the direction in which A should travel in order to intercept B. And we need to give our answer as a bearing. So in order for A to intercept B, that means that if B was the observer, A is going to be heading straight towards it. So that tells me that the velocity of A relative to B, well, it's going to look like this here. Okay, that's going to be the velocity of A relative to B. So to B as the observer, A is going to look like it's coming directly towards it. Okay, so I'm just going to put that over here, and we'll carry this north line over as well. Oops. And we've got an angle of 65 degrees between those. Send that out a little bit. So we've got 65 degrees between those. Okay, and that's the velocity of A relative to B. Now I know that the velocity of A relative to B is going to be equal to the velocity of A take away the velocity of B. And in this question, the velocity of A is our unknown value, so I'm going to write this as the velocity of A is going to be equal to the velocity of A relative to B plus the velocity of B. Okay, so I've already got my velocity of A relative to B set up. That's in that direction there. I'll just move this over here. Okay, and my velocity of B, we're told, is on a bearing of it's travelling due north at a constant speed of 10 kilometers per hour. So I can draw that in. And that's going to be going due north at 10 kilometers per hour. Okay, so here I've got the velocity of A relative to B, and over here I've got the velocity of B, and these two added together should give me the velocity of A. We'll do that in that. Okay, and that there is going to be my velocity of A. And I know my velocity of B is 10 kilometers per hour, and my velocity of A is 18 kilometers per hour. So I'm just going to write that as an 18 over here. Okay. Right, so we've got the value of 18 and the value of 10 there. So in order to work out the direction A should travel, okay, we're looking for this angle here. So if I mark on the angle here that I know, that there is going to be 115 degrees. That there is 65 degrees, so this here is going to be 115 degrees because they need to sum to 180 degrees. Okay, so now I know this angle and the opposite side, and I want to know this angle here, which I'm going to call alpha, and I know this side here. So using the sine rule, I should be able to work out this angle, because sine of alpha over 10 is going to be equal to the sine of 115 over 18. Okay, so sine alpha is going to be equal to 10 sine 115 over 18. So using my calculator, I can work out that alpha is going to be over here. So we've got 10 sine 115 over 18. So that's going to be what sine alpha is equal to. So alpha is going to be equal to 30.2 degrees. Okay, so we now know this angle here is 30.2 degrees. I want to know the bearing, so I want to know this angle here. So from the north, we want to know what this angle here is. So if that's 65 and that's 30.2, I can do 65 take away 30.2, and that's going to give me 34.7 degrees. So my bearing is going to be and that was 35 degrees, let's call that. So it's going to be 0.35 degrees. Okay, so I now know part A there, and I've worked out the bearing. Okay, in part B we're told that in fact the ship A travels on a bearing of 0.65 degrees. So we're being told now, actually we know the direction of ship A, it's travelling on a bearing of 0.65 degrees. Okay, so first of all we want to find the distance between the ships when they are closest together. Okay, so in order to answer this we need to go in two steps. We first of all need to draw a new velocity triangle. Okay, so we can mark on what the resultant velocity is going to be. So the velocity of A relative to B, sorry I should say. So we want to mark on what the velocity of A relative to B is going to be. And then we want to transfer that onto a distance diagram to find out when they are going to be closest together. Right, so we're going to use this top formula over here because my velocity of A relative to B is my unknown now, and that's equal to the velocity of A take away the velocity of B. Well, the velocity of A we now know is going to be going on a bearing of 65 degrees. So let's we'll borrow this north from here, and we actually know that this is going to go on a bearing of 65 degrees. So our velocity of A we did in purple before, so we'll do it in purple again. And that's actually going to be going in that direction there, with an angle of 65 degrees in between. And we know the velocity of A is actually going to be 18. Yeah, so that's the velocity of A, and that's going to be 18 kilometers per hour. Okay, and also we have the velocity of B that's going at 10 kilometers per hour. But using this, we've got the velocity of A take away the velocity of B. So now I've drawn my velocity A over here. When I draw my velocity of B, which is going to be the same as what we had before, so I'll just borrow that from there. Now that would be the velocity of A plus the velocity of B, but we want the velocity of A take away the velocity of B. So I'm going to draw that down here. Okay, so the velocity of A relative to B, therefore, is going to be going in this direction here. Okay, and that's going to be my velocity of A relative to B. Okay, so the velocity of A take away the velocity of B gives me the velocity of A relative to B. Okay, right, so now that I've got that drawn in, I need to mark in the angles that I know. So these are alternate angles over here, so that there is going to be, again, that there is going to be, try again one more time, is going to be 65 degrees. Yeah, so that one's 65 degrees and that one's also going to be 65 degrees. Okay, so over here now I can see that I've got an angle and then two sides either side of it, and I want to work out what this speed here is. Okay, so I want to work out what this speed here is first of all, and in order to do that I can use the cosine rule. So I'm just going to call this over here, we don't know the value of the speed here, so I'm just going to call that x. Okay, so using the cosine rule then, I've got a squared is equal to b squared plus c squared, take away 2bc cos a. So in this case it's going to be x squared is equal to b squared plus c squared, so that's going to be 10 squared plus 18 squared, take away 2ab, so 2 times 10 times 18 times the cosine of the angle in between here, which is going to be 65 degrees. Okay, so if I put that into my calculator, I've got 10 squared plus 18 squared, take away 2 times 10 times 18 times the cosine of 65, and if I square root that, that will tell me that x is equal to 16.5 kilometers per hour. So x is equal to 16.5 kilometers per hour. Okay, right, so I now know what x is over here. So I also want to know this angle here, which I'm going to call theta. Okay, so this angle I can use the sine rule to work this out. So that's going to be sine theta over 10. Is equal to the sine of 65 over x, which is 16.5. Okay, so sine theta is going to be equal to 10 sine 65 over 16.5. So again, I can put that into my calculator. So I've got to keep the 16.5 here, and I'm going to say I want 10 sine 65 divided by my answer, which is 16.5, and that gives me 0.549, and to change that into an angle, and that tells me my angle is going to be 33.3 degrees. So theta is equal to 33.3 degrees. Okay, so my bearing here is going to be 65 plus 33.3 degrees. which is 98.3 degrees, or to the nearest degree 0.98 degrees. So that's the bearing here that our velocity of A relative to B is going to be. Right, so we're almost there now. So we now want to find the distance between the ships when they're closest together. So I'm going to come over to this diagram over here. Now if I take this, okay, and I'm just going to move this over here. So this is now my distance diagram, and I know that with B as my observer, so with B as the observer, it's going to appear that A is going off in this direction here, and what we're looking for is when this is going to be closest to B. Okay, so B is in a fixed position, and it appears that our ship, and if I just mark it with if I draw a little ship here, there you go, there's my little ship, and it's going to appear that the ship is drifting off in this direction here, going along here, and we want to know at which point the ship is going to be closest to this point here, to this point B. Okay, so, and it looks like it's going to happen here when it's perpendicular to this direction of the relative velocity. So what I'm looking for is I'm looking for this situation here, and I'll mark it on with a okay, so we're looking for that there where we have a right angle over here. Okay, right, so we know that this angle here, is going to be 33.3 degrees. I'll mark that in there. We've got 33.3 degrees. I've just realised we didn't actually need to work out this bearing here. I've done it now, but we didn't actually need to work that out. Okay, so this angle here is 33.3 degrees, and we've got a distance here of 12 kilometers. So to work out the distance between the ships when they're close together, we want this opposite side over here. Okay, so to calculate that, we're going to do 12 sine 33.3. So this side here, which I'm just going to call D, okay, D, and D is going to be equal to, I'll write it over here, and it's going to be 12 sine 33.3. And that's going to be 65 from that. That's going to be 12 sine 33.3, which gives me 6.60 kilometers. 6.60 kilometers. Okay, so that's going to be that distance there. Okay, so part one, so to find the distance between ships when they're close together, it's going to be 6.60 kilometers. So that bit's done. Okay, so all of this was be part A. Okay, so we now want to do part II. So this is find the time when the ships are closest together. Okay, so in order to work that out, I need to know this distance here Okay, so from there to there, which is going to be 12 cos 33.3. Okay, so if I call this distance, I'll call it h, and we know that h is going to be equal to 12 cos 33.3. Okay, and so let's work that out first. So 12 cos 33.3, I'm not going to carry my error forward this time, so I'm just going to put in 12 cos 33.3, and we've got 10.03, so I'm going to say h is, we'll call it 10.0 kilometers. Okay, so this distance here from here to here is 10 kilometers. So once our velocity of A relative to B has traveled 10 kilometers, that's when it's going to be at the closest point to B. So the magnitude of our velocity of A relative to B, we worked that out earlier, is actually going to be 16.5 kilometers per hour. So I need to work out the time it takes to travel 10 kilometers at 16.5 kilometers per hour. So my time is going to be my distance divided by my speed, and that's going to tell me my time. So my time is going to be equal to 10 divided by 16.5 divided by 16.5, and that gives me 0.608. That's going to be 0.608, and that's going to be in hours. Okay, so we're being asked to find the time when the ships are close together. It starts off at noon, and 0.608 hours later they are closest together. So I'm going to convert this into minutes. So if I times that by 60, and that tells me it's 36.5 minutes. So T is equal to 36.5 minutes. Okay, so the time that they're going to be closest together, well, the actual time will be 12:36 p.m. Okay, so the time will be 12:36 p.m. when they are closest together. Okay, I hope you found that useful. Thanks very much for joining me, and I'll see you next time.